is, okay, that is not good. Let me see if I can switch this around before I display it. Alright. 1280 by 1024. What are we doing here? Why is this not? I had the same problem with the Orange County stuff. Nope. Oh, we're going to go back to where were we at? 1440 by 852.
How about the optimize for?
Oh, okay, sorry about that. Where is optimized for?
Right below you.
Oh, I see.
Yeah,
Whoa.
that's a lot better.
So over on this side of the screen. All right. Well, you know, let's see. I'm mainly concerned about this, which looks better. Okay. Let's go from here. I'll stand up at least for a little bit. I apologize. Let's see. I'll go backwards here in a second, but we will be talking a tiny bit of futures, and the Oracle disclaimer always applies because I work for Oracle. And this is why I'm late, because the family and I were at SeaWorld, and it's spring break for the kids. So instead of me just coming down here to do this, we turned it into a family thing. So ran a little bit late because we were having some fun. John Clingan from Oracle. I'm a product manager historically for Java Enterprise Edition, and this was the case at Sun before Oracle acquired Sun Microsystems, and at Oracle, and I'm also the product manager for the GlassFish application server. And I recently picked up a couple of other projects. One is EclipseLink, so pretty soon I'll be an Eclipse committer as soon as I basically fulfill some of the requirements. And a project called Avatar, which is basically server-side JavaScript for the Java virtual machine. Right, so it's kind of the node programming model and some higher level services running on the JVM. So those are some projects that I'm kind of responsible for. And the reason why I'm here talking about Java, right, which is kind of a lower layer than Java EE, is because we're evaluating what to do for Java Enterprise Edition, Java EE8. And obviously, you know, if you go by historical standards, the Java EE version matches the underlying JDK version in terms of the minimal version that's supported. So Java EE8, which is probably a couple of years away, is going to require at least Java 8. So in other words, what can we leverage in Java EE APIs and technologies from the underlying improvements that some of which you're going to see today. Okay. And I think, okay, yes, I was having fun earlier. And I reserve the right. Okay, so I used to do a lot of software development, but since I do a lot more product management these days, I'm not as detail-oriented around some of these technologies as I used to be, but ask away if there are questions, and I'll do my best to respond. Okay. So there's a lot of new features in Java SE. And didn't think I touched anything. Holy cow. There's a lot of new technologies. We're not going to get into it all. Or I could say we have 20 slides on each feature, whichever way you prefer. So I'm going to cover, I think, especially around Lambdas and streams, I think, which is what most developers are probably interested in. We're also going to talk a little bit about some of the other features. Out of curiosity, how many here are still running on JDK 6? A couple. JDK 7? Awesome. Okay. And JDK 8 in production? Yeah. Woo! Okay, he should get the raffle, yeah. And how many have actually gotten their hands dirty playing around or learning the Lambdas and streams? Okay, so feel free to ask questions or correct me if I'm wrong. I'm perfectly cool with that. I like to make this pretty interactive. And in terms of timing, what's kind of the schedule between now and, is it 9 o'clock is the end, or is it 8:30? What do you guys normally do?
Take a break around 8 o'clock.
Okay.
You can go till 9, and if we sweet talk Alexandra, we might be able to go through
Whatever
No.
works, yeah, whatever you need to do.
Oh,
Mine's in.
The boss has spoken.
Okay. All right, so the biggest change, Java SE is the biggest change in Java since Java SE 5. It's, or some will even say probably since, Java was first released. So a lot of new, not just new features and APIs, but also some fundamental changes to the language itself. And the changes to the language, especially around Lambdas, also offer us the opportunity to also improve the APIs themselves in ways that we couldn't have done before, thanks to some other features I'm going to be talking about. So the main goal of these changes are better developer productivity, more reliable code, because we're going to pawn off a lot of the work on some of these APIs like streams that we might have had to have handled before ourselves. And I think what's really important is better utilization of multi-core and multi-processor systems that we even have on our laptops today, right? So this is, I think, an 8-core, Mac laptop. And so how can we leverage all the cores that we have in this in these systems today? And we develop code now, or we can develop code, so that's no longer inherently serial or parallel. So what you're going to see with the API is I can, with a very simple flip of a switch, in terms of the Streams API, take code that was intended to be serial, well, not even, intended is the wrong word, that is implemented serially to make it parallel, very simply. And the Streams API offers that in a very simple way. Because we approach the problem a little bit differently. So Lambda expressions, and what I'm going to do after I do a little bit of intro here is switch over to NetBeans, and then we'll do a lot of code showing. Again, almost all machines are now multi-core, multi-processor. I like this couch thing, I'm getting comfortable here. We need to make it simpler to write multi-threaded code. How many here, for example, have used the fork join API in JDK 7, right? Straightforward, easy, right? Well, it can be, but it's a lot easier when the libraries take care of a lot of the hard work for us. So we need to make it simpler. Java has always had the concept of threads, right? Java lang thread. And we're even using the concurrency utilities, and there's the fork join framework I just talked about. And what we can also do is, with Lambda expressions, write better library code. So you're going to see that some of the libraries, especially the collections libraries, but there's some other enhancements that have been done to the existing libraries. And what's nice is they've done this in a way that maintains backwards compatibility. So because we've got this great new feature called Lambdas, we could have created this whole separate set of APIs that were Lambda enabled. And it'll become apparent here in a second what Lambdas look like. But then all that code that we have, it's kind of like you would have to learn the old way and the new way, right? What we've done is we've modified the language to let us evolve the libraries that we already have to take advantage of Lambdas. Okay. So let's switch over, and we're going to do a lot of coding here at this point. Well, not a lot of code, but focus on the code that I do have. Let's see here. All right, can everyone see that in back? It's big enough? Okay. How about now? So, excuse my really long package names. But besides that, if we look here, what do we have? A traditional interface in Java, right? We have the name of the interface, and then we have a method within that interface. So any class that implements this interface has to implement this method. Now the problem comes in when I decide at some point in the future that this one method is no longer enough, and I want to add a second method. What do I do? Right? Well, if I have many consumers of this interface, I'm kind of screwed, because if I make a modification to this interface, then they'll all have to go change their code, right? So that's kind of the negative impact of having an interface. So what's really neat, really cool feature that they added in Java 8 is the ability to have static methods within an interface. So now I can actually add not just a method definition to an interface, but I can actually add an implementation of code. Right? So what you see here is this is, it's pretty simple. This default or this method that some subclasses or some class that implements this interface is going to have to implement. It just prints a string, right? System.out, for instance. This is going to return the length of the string. And what we've done here is we've just evolved this interface. So any class that currently extends this interface or implements this interface now has the length method available to it, right? Whereas in the past it didn't. And they also have an implementation. So this basically lets us, one way of evolving an interface. Another way is we now have the ability, like the method definition up here, to provide a default method. And basically a default method is kind of like what we have up here, a static method. It's actually an implementation. And with this implementation, in this case, it just transforms a string and returns an uppercase, right? Really simple stuff to get the point across. But a class that actually implements this interface can actually override transform to do something different, right? So just like you would if you were extending another class, you can override, unless it's final, you can override another method, right? So now you can do that with the default implementation within an interface. With static, you can't overwrite, right? With a default method, you can. So what you're going to see, for example, in the collections API, is an awful lot of use of this feature to actually add Lambda support to the existing collection interfaces. And we'll see examples of this. So we've evolved the collections API, letting you use the existing collections APIs that you use today. All your existing code will work. But now if you're getting your feet wet with Lambdas, you can actually start using some additional APIs that are available to you. And that's all enabled by the fact that we can now evolve interfaces.
Any
Yes.
problems with collisions where two interfaces offer the same default method?
Yeah, there is a set of rules. I apologize. This is where I will go back to. I meant the same question. I apologize. The same question was actually asked at the Orange County Jug, and yes, there's a set of rules to cover that.
I believe it won't let you.
Sorry.
I believe it won't let you. Unless
It
you
compile
you
time.
have to
Yeah,
explicitly break.
Yeah, I think the way you might solve that is you would then have to create your own implementation that calls super on that interface to call the implementation in the interface that you want. So that's one way. There's some other rules, but okay. All right, I got to use that slide once already. See if I get to use it again. All right, so if we take a look here, let's see if I can go full screen. This is just a very simple Java class that basically prints out the string. It implements that single method, right? So if I run it, it's going to basically print out hello Jug. So I did this via Maven. I don't know why. Is it here somewhere? Oh, there it is. Hello, Jug. Sorry, I don't know why I did this in Maven, but okay. Now, if we go back and take a look at extension 2, this is a little bit different now because we're overriding the same print string, which does not have any kind of implementation in the interface. But here we're overriding the implementation, the default transform method that we had in that interface. So this is just an example of how you can actually override the default implementation in the interface. In this case, well, if you recall, transform said 2 uppercase and any string. This implementation will just do 2 lowercase, right? So what we've basically done, I kind of showed this example a little bit differently with the OC Jug. Oops. So there's hello jug. I called the static method in length that was defined in that interface. And then this is the two lowercase from the transform method that I overrode. So that's kind of a neat way of, evolving the interfaces that you have. And let's take a look at the next step. Let's look at the lambdas. I'm trying to remember which way I did. Let's see. That's why I took my notes, because I created these. I want to make sure I get them in the right order. Okay. Okay. But I did that because I think that's first. All right. No, let's do vertical inner class. This way. All right. Here's how we might have normally implemented historically a runnable. If you've ever done threading in the JDK, at the JDK level, you probably use the thread class, historically speaking. So if you look at the runnable interface, runnable is basically just a method, an interface that implements one method called run. You pass that to a thread, it'll run whatever this is in this run method within the context of that thread. So what you'll see here in runnable is also something new that I actually didn't have in the interface that I showed you earlier. It's something new called functional interface. So functional interface basically means that an interface has one abstract method. And if you look throughout the JDK libraries, you'll see lots of examples of this, right? If you're using the JDK events, there's basically an interface that has a single method that catches the events. If you've done swing programming, right? Lots of callbacks are done via via interfaces where you just have to implement a single method. So what's interesting is this is the approach that Java takes to functional programming and lambdas. So,
I have
yes?
a question about that runnable. What is the significance of the abstract keyword in that method? Is that not abstract anyway, or?
That is abstract in the context of an interface is actually optional. So you're correct. I could have basically, if I did, well, I can't. This is in the library, but yeah, if you left out abstract, it would still be a valid interface definition.
Well, public one, I meant, sorry.
Yeah, good one.
They'd all have to be public. So is that abstract in there? Well, it's redundant, but it was never in this interface before Java 7.
Good question. I don't know if it was in there before, but it is redundant in the fact that, just to give you, well, in the example with my interface, right, there's no abstract here. If I add abstract, it won't make a difference at all.
But it's probably been in there since JDK 1, which is when that interface was originally defined.
Was it even valid syntax in JDK prior to 7?
That's a good question.
I've never seen that.
I suspect it was. I bet you if we go back and look, but I could be wrong. But
because interfaces never had implementation prior to Java 8, right?
correct.
So what would be the point? Anyway.
Yeah. So what this class basically does is it creates a runnable. I might do intercast, darn it. I'm stealing my own thunder. Okay, so what we're going to do is implement this using an anonymous inner class. Right? We create an anonymous inner class that implements the run method. What the run method is going to do is say basically hello world, and then print out the name of this class. Okay. What's interesting about this? Well, first of all, can anyone see anything that you couldn't have done in JDK7 in this simple line of code. Yes. And what's different between, what's missing? Final.
It's not final, yes.
It's not final. So in JDK7 and earlier, to actually have code or a variable being referenced within an inner class, it would have had to have been final. And what this is the kind of the first thing that we're really seeing in JDK8 here that is new, and that is that variables that are being defined outside of an inner class or a Lambda expression, which we'll get to, that is used inside of that inner class is actually called effectively final. That means this is implied final. I still like having the word final there, but it is effectively final. So if I actually, for example, decided to say string plus equals now, I'm going to get an error. Because now it's saying local variable references an inner class that must be effectively final or final. Right? So now it's no longer effectively final because I've actually changed it. Right?
So what's the difference? I mean, why not just keep it final? I mean, it looks like syntactic sugar to me.
No, it does, but once you start getting the lambdas,
Okay, there's a reason. I'll hold on
it
for that.
becomes more, I think, more of a functional way of doing things than the way that we've been doing it with the traditional Java code. The other thing is, what do you think getClass.getName is going to print out? Any guesses? Okay.
Or something.
Yeah, $ something. It's got a $ in there, right? And why is that? Because the JDK is actually compiling a class that's being stored on the file system, and that's the name of the class, right? That's the name of the inner class that we just defined. Okay. Now let's look at this from a Lambda expression perspective. A couple of things about a Lambda expression. It's basically syntactic sugar, to use a word, syntactic sugar for inner classes from the way it's expressed from a coding perspective. What you have here is the arrow operator. To the left of the arrow operator are the methods, are the parameters that you pass into the method. In this case, with a run, there are no parameters, so it's just an empty set of parentheses. And to the right, you actually have the block of code that you would normally define in a Java class, right? So, or in a Java method. So everything here looks normal, but this is kind of what's new. Right? Now we're printing hello world, referencing this effectively final variable called string. Question, what's it going to print out now for the class name?
Same thing.
The way he asked the question, he had
A trick question.
What's actually interesting is there is no intermediate class format. What's really being done, from what I understand, the way this is actually being implemented, is it's actually implementing this as using invoke dynamic from the JVM, which was something that was added in JDK7 as a way for dynamic languages to do a lot of dynamic things that they do in terms of dynamically defining methods and executing them and so on.
It's not just syntactic sugar.
Yeah.
It's not just a syntactic sugar. That's why I said from a code, when you look at it, it looks it looks like it's syntactic sugar, but there is a little bit of a fundamental difference.
Does that have any performance impact?
Does it have a performance impact? No, it's being optimized away at the JVM level. And what's actually interesting is if you start taking streams into consideration, and the fact that if you want, you can now parallelize your code, that would go away anyway. But I don't think there's, from a compiler perspective, that there's actually any performance hit at all. Because there's nothing dynamic being done here, right? This is going to be compiled down to static bytecode. That'll then get jittered by the JVM. And it'll effectively be a method call.
I guess I'm curious if that's a positive.
Is it a positive performance impact? I don't think, just for example, if I code this versus the the interclass version, you probably wouldn't notice anything whatsoever, right?
You end up with one fewer class.
You'll end up with one fewer class. Okay, so there's maybe a little bit of a heap difference, right? But once the JIT kicks in, it'll all go away anyway. It'll just execute this here anyway.
Where do the bytecodes for this end up then?
Sorry?
Where does the bytecode representing those two print lines end up? With which class?
Which class? I don't know the answer to that one. Go back to the other thing.
Take a drink
It's
now.
not gonna go in the
It could be
class,
like
it's
an
gone.
anonymous method, basically inside runnable Lambda.
Yeah, how it's actually implemented. So what's the scope of this, right? And that's a good way of asking the question. And the scope of that is going to be within the context of this method call. But within the context of run it. So it could be defined or compiled within the class itself, defined as a new method, right? That's maybe one way.
And this only works with classes that are, or interfaces that are declared runnable interface.
Yeah,
No?
good question. It's actually
Or-
where the functional part comes in is the fact that what we're passing in here is a reference to a functional interface. A functional interface, if you recall, this is kind of optional. The compiler is smart, kind of like add override. You don't need to say add override, but it's an indication to the compiler that you're intending to do something, and it's also an indicator to the developer that you're overriding something, right, without having to go look. And that's a lot of what functional interface is. It basically is a way of saying that this interface is a functional interface.
And I think it also serves the purpose, but if you put two methods in there, the compiler will complete.
Yes, if I, I'm doing it here, but if I go back to this other, if I go back to my interface and I define another class, public abstract, okay, I don't need that. Void, hello world, and it just prints out the hello world itself, let's say. Everything looks fine until I do that. Let's see here, unexpected functional interface. It's not a functional interface. Multiple non-overriding abstract methods, right? So now it's saying, okay, what I've got here are two methods that are abstract, and you're only allowed to have one. Now, the reason this is important, because if you think about a passing functions around, a function is just a single executable block of code, right? And that's basically what a functional interface is you're saying, here is a single method that I'm passing around. Typically when you pass things around, you're passing around state, right? With Java, but with functional programming, you're actually passing around behavior. So this is defining the behavior that we're passing around. Somebody has to implement it, but it's still behavior that we're passing around. And what we're saying here is, well, that one functional thing that we're passing around, that one piece of behavior, we're defining using a Lambda expression here, and I'm passing into the runnable, which in JDK 8 is a functional interface, right?
Can you cast these to runnable rather than creating burn?
Sorry, cast them to runnable instead of?
Yeah, so if I wanted to do away with the runnable R there and just cast it within the new thread, does that work?
Good question, and we're eventually going to get to that, but could I get rid of this and just take this code and stick it inside there, right?
Yeah.
Basically, yes.
So closure like.
Yeah. Let's just do that. Except, I got one thing to fix. Let's see here. Rename thread to runnable Lambda. Hold on, what did I do wrong?
Semicolon?
Comment.
New thread.
25 through 27, maybe comment too.
Ah, yes, thank you. And cut it out. There we go. So there's an interesting dynamic going on here that I kind of saved toward the end. So I'm not going to give it all away here, But basically, what we're saying is that run method that you typically pass into a runnable is now this block of code right here, right? So that's implied, okay? All right, and it's one reason why a functional interface can't have two abstract methods, right? Because then it's no longer really a function, it's an interface. Okay, so let's go back. Okay. Okay. So let's take a look at another piece of code here. With this piece of code, let's see if I can go a bit higher. We have just a list of integers that you would do in any other, JDK version. Okay, 5 or above. Then you say, let's not worry about for each for now, but you have array for each, which is basically an iterator. And for each element of this array, what we're going to do is, oops, why do I have consumer? See, that's the problem. Is I was showing, I changed this code in the last jug from what it originally was, just like I did before. Okay, so what this is basically saying is that it's going to print out each one of these. Okay, so the consumer interface, if we look, first of all, it's a functional interface, so I could define it using a Lambda expression. And it just says this performs an operation on the argument. What you'll find is there's some what we call convenience functions in the functional interface package. Actually, I'm going to do something here. I forgot to do this at the beginning. First, we should do this. If you go Google Java 8 launch, it'll take you to this page, and this goes into basically a bunch of, except for the keynote, where they talk to the JDK engineers who came up with a lot of this stuff. A lot of sessions on what's new in JDK 8, right? So Java SE8, the new datetime API. We're going to get into some of these, but these are all like short 10-minute introductions to features, some of which I'm going to talk about, some of which I'm not going to be able to talk about. So I just wanted to bring that up to you. A second thing I wanted to bring up is the Java 8 tutorial, or the Java SE tutorial, has been upgraded or updated to include all the new things in the JDK. So this is another good source of learning the new features. Java 8 API docs. This is what I really wanted to show you. So what you'll see is there is now a java.util.function package, and these are a bunch of predefined functional interfaces. They're intended to be pretty generic, and one of them is consumer, which I just used, and it just says whatever you pass into it, or it's a consumer of a type, I should say, and whatever comes in, you just execute an operation on it, okay? One of the things you'll find is you just can't take that Lambda expression that you saw with the parentheses and an arrow and just pass it around anywhere. You have to pass it into something that accepts a functional interface, an interface with only one abstract function. And instead of you having to create some of these boilerplate one method interfaces, a lot of them were created for you. And that's what this package has, java.util.function. Okay, so let's go back. So what this consumer says is I'm going to consume this thing that I'm getting as a parameter, this integer in this case, and then you can execute some code on it, right? So we're just going to say go ahead and print it out. So it's just going to print out all the integers, right? Pretty simple stuff. Now let's look at it from a slightly different perspective. Now we're going to do it with a functional interface. And you notice what's different this time is I do have a parameter. If you recall with the 1, I just had empty parentheses, right? Syntactically, if I only have one parameter that gets passed into a method, I can leave the parentheses out, or sorry, I can have the parentheses. I'm passing an I into this block of code over here. This is similar to the other code that we saw with runnable, right? Oops. Okay. If you have only one statement in the method, you can eliminate the block. And if you have only one parameter that you're passing, then you can eliminate the parentheses. Okay? So if we actually run this code, it'll just basically do the same thing. Just prints out the list. Now we can go a step further. And we can shorten it to what we call a method reference. A method reference is just what it sounds like. It's a reference to a method. It basically says that for each integer that we're passing in, and we know that it's integers because the array is, or the list is of type integer. Why did I call a list an array? I don't know, I'm sorry. So, and we know that println takes basically a parameter, so we're just going to print out the thing that's being passed in. What we're going to pass is, what we're passing as a function is println, and println is going to print what's being passed to println, which is whatever that element in the list is. Kind of hard to grok. Yes?
So you touched on before about parallelization, how some of these new kinds of ways of writing code can be parallelized. What does that mean for this statement? Does this fall into that?
Not yet. But we're going to get there.
I have a question. So,
Yes.
So you're showing how you could omit a lot of code if it's a single line. In this case, it's a void function. If it's a function that returns something, do you have to return it there, or can you return also?
Good question. So there's a couple of things going on here. Let's see, do I have other? So I'm doing it in a little bit of a different order. There's something going on called type inference, and from my understanding, implementing lambdas and just from syntactically was quite easy to do from a JDK engineer's perspective. But what was really hard was to infer type. Because what we're doing, if you look here, we're actually saying this returns a void, and it accepts an integer, one integer parameter, right? What we've done here is we never defined a return type. It's inferred because we're not returning anything, that it's returning a void, that it's a void, and it's inferring that that I is an integer because this is a list of integers. So it's getting the type information from the context that the code is actually being executed. And that's what's also going on down here.
So that's done at compile time or at runtime?
It's done both at compile time and runtime, I think.
And there's no performance hit for doing that?
At compile time,
Compile time doesn't really matter.
yeah, compile time. At runtime, I got to think about that because I'm trying to think of cases where you can dynamically define a lambda, right? Outside of using a bytecode compiler, right?
Well, how does it do the inference? Does it use reflection?
No, it doesn't. Well, at compile time, it does it. Well, at compile time, it does a compile time. At runtime, I don't know. I'm going to go back to my previous point.
Well, the only reason I mentioned
Damn it,
it
Jim.
is because reflection is expensive.
Yeah, reflection is expensive. I'm not sure what if anything is being done at runtime. Okay, I know it's definitely being done at compile time. Okay. So basically, anything that passes in X number of arguments, and this single method takes X number of arguments, then you can collapse it down to a method reference.
And if print line returns something, would this not work because it doesn't know to discard the result?
Let's do it one time. Go to declaration, I know that. Okay. So it takes a consumer, right, which is what we passed in here. Which is what we passed in here. So if I actually, oops, let's just go back. Let's go look at consumer. Consumer takes a void. Sorry, the method signature is it returns a void and takes something of type T as a parameter. So it would fail if we tried to pass in a function that actually returned a value, because the type signature of those two functions would no longer match. Does that make sense?
Mm-hmm.
And so that's, again, where the type inference comes in. Okay, in fact, let's go on to type inference.
Before you move on,
Yes.
The
How are we doing on time?
functional interface, you said that you were
Okay.
can only have one method.
A functional interface can only have one abstract method. Remember, you can still have static and default methods,
Okay.
but only one abstract method.
System.out : means you can call any method for a method reference.
But what you're passing in, let's go back. If we look,
Another thing is system out print line is overloaded too.
Yeah, so that's what I was trying to get at, is that the method reference.
so let's think about type inference.
Well,
It knows
what
that
you're
You need
passing
the
in
one
is
that
the definition of the
takes
accept
an
method.
integer.
And print line
So
is the
it should be
contents of that
passed in.
method.
Yes.
Right.
So what it's going to do, let me think.
Yeah, the print line takes an object.
You should look up a system out print line that takes an
It's
integer.
overloaded.
What was that?
You should just look up a system out print line that takes an integer.
But
Even the one with no arguments at all,
yeah,
that
but
just
the
prints
integer
one.
will be.
This is gonna know that it's an integer from the array.
So let's do make before break. Turning into. Sorry.
That's just a basic.
Double click.
Really, really complicated.
Let's go back.
Fine by us, right? I'm using reference, so just use
I think reference.
Why I've never been to a compile.
Okay.
Like it knows from array that it's integer.
It takes a void. Sorry, returns a void. And takes one object.
Oh, to string, easy.
Two string. Because what it's going to do is it's going to take that integer, box it. Sorry, actually it's already an integer, so it doesn't even have to box it.
Yeah, it's an integer class.
So we're passing in a reference to this method, which is not a functional interface, and it doesn't have to be. We're just passing in a reference to a method.
And it'll just create like a lambda basically around it.
I'm not sure how it does that, to be honest.
Like it could,
It's a
it
language.
could conceivably just do what it did, what you had done manually before, and code wise.
Yeah, it could have.
So.
How it's implemented, I'm not sure.
It's magic.
It's magic. It's 8 o'clock. If you want to do a quick break.
Okay, let's go ahead and take.
Saved by the bell.
Yeah. Leave groups, you can rearrange the chairs as you see fit. Restroom keys on the back still, I hope. And there's probably some more pizza. So please, take forward. Yeah.